Alright, let's continue on with problem 111. Same thing here is going to happen. We're going to have three different denominators, so I'm going to multiply all three of them together to get a common denominator of 3x times x plus 2. So this one already has the x, so I just need the 3 and the x plus 2. So I'm going to multiply it by 3 and x plus 2. So on the top, 3 times x plus 2. This one here has an x plus 2 but needs the 3 and the x. So I'll multiply the denominator by 3x. So I'll multiply the numerator by 3x. And then this one needs the x and the x plus 2. Alright, so they all now have a common denominator. Now I can rewrite the equation from the numerator. So 3 times x plus 2 plus 1 times 3x is just 3x equals 1 times x plus 2. And we're going to distribute 3x plus 6 plus 3x equals x squared plus 2x. So I see an x squared here, so this tells me it's a quadratic. So I want to solve this one by moving everything to one side to create a trinomial. So I'm going to move everything this way to keep my x squared positive. So real quick, I'm going to combine those in the next step. So I have 6x plus 6 equals x squared plus 2x. I'm going to subtract 6x. So minus 4x. And then I'll subtract 6. So this gives me 0 equals x squared minus 4x minus 6. And that does not look factorable. So if we're trying to find out what x is equal to, we need to then solve it somehow. And so I think that I'm going to use the completing the square method here because I like that method. And sometimes we just need a review. So if I were making a actual square, I would need I'd need to add 4 singles to this, but what I have is -6, so I'm actually short more than I need total. So I'm going to rewrite this x squared minus 4x. So I need to have a plus 4. So I can't just add 4, right? I need to subtract that 4 as well. So I added 4, subtracted 4, so now I have something that's factorable. And then I have a deficit here, or subtract -10. So this is going to give me x minus 2 squared minus 10. And now to solve this, I can add the 10 over here. I can then take the square root of both sides, and I'll get plus or minus the square root of 10 equals x minus 2. The square root and the square kind of cancel each other out. Then we'll add 2. So I'm going to get x equals 2 plus or minus the square root of 10. So it's going to give me two solutions there. So, lost you there a little bit. So when you have a rational function like this, which I should have been checking the entire time, I forgot about this. I might have to go back and talk about if any of these are called extraneous solutions. Number 26 does not. What that means is if you plug in this into, it creates a 0 in the denominator. So -3 would be -6. That would be a -2. So that's okay. Let me go back real quick and just double check, because that's not something we should forget. And I don't really have to worry about any of these because they didn't have any variables in the denominator, but this -3, that would make all the denominators 1, so that one's fine. 2 minus 2. This number 22, if I plug in a 2 here, that's going to give me zeros here in the denominator. So x cannot equal 2 actually. This one does not have any solutions. Negative 8 for this one. Looks good. 7 for this one. Looks fine. So it was just number 20. Alright. So sorry about that. We're going to move on to number 113 next. Alright, so here we go. X squared minus 9, that is x plus 3x minus 3. And that matches our two denominators here. So I need an x plus 3 for this first one. So I'm going to multiply by x plus 3 and multiply by x plus 3. Over here I need an x minus 3, so multiply by x minus 3, x minus 3, and then I don't need to do anything here. So common denominator all the way across, I get 2x times x plus 3 plus 6 times x minus 3 equals negative 28. That's the negative sign, and then the 28. So I'm going to get 2x squared plus 6x plus 6x minus 18 equals negative 28. Combine some like terms, I'm also going to add 28 to both sides. So I get 2x squared plus 12x plus 10 equals 0. All three of those are even, so I'm going to factor out that 2. Hopefully it'll make solving this thing easier. Alright, so this is actually factorable because 5 times 1 is 5 and 5 plus 1 will give me 6. So this is going to give me 2 times x plus 5 times x plus 1. And so x is equal to negative 5 and then x is equal to negative 1. And when we look at this, negative 5 will work for all those denominators, so will negative 1. So both answers are true. Alright, 139 gives us the equation shown there. It says a company wants to increase the 10% peroxide content of its product by adding pure peroxide, 100% peroxide. If X liters of pure peroxide are added to 500 liters of its 10% solution, the concentration C of the new mixture is given by that equation. How many liters of pure peroxide should be added to produce a new product that's 28% peroxide? So basically what we're saying is here is we want our concentration to be 28%. So 28% would be 0.28. And we have this equation that we can then solve for X. So this one's more like a proportion where we can cross multiply. So technically really what I want to just do is multiply by x plus 500 on both sides. And so when I do that, I'm going to get 0.28 times x plus 500 equals x plus 0.1 times 500. So I can simplify. So 0.28x plus 140, I put that in my calculator, equals x plus 50. And then we can then combine like terms here, so or move things to the same side. So I'm going to subtract the 0.28x from both sides. And that's going to give me 140 equals 1 minus 0.28, that's 0.72. So 0.72x plus 50. And then we'll subtract 50 from both sides. So that'll give me 90 equals 0.72x. And then we'll divide both sides by 0.72. So that's going to give me x is equal to 125 liters. And that's it. 125 liters of pure peroxide would be added. Alright. Alright, last one. So this one wants us to solve for C. So let's see. I think the first thing that I would like to do is get rid of this N because I don't want it. I want to get only terms that have C. So I'm going to divide by N and divide by N. So it gives me V over N equals C minus S over L. And I'm going to get a common denominator here. So I'm going to multiply, I need L here. So I'm going to put an L there. And if I divide this one by L, I'm going to need to divide this one by L as well. And if I divide this by L, I need to multiply the numerator by L. Same thing over here. I think I don't like what I just did there. So I'm not going to divide by the N. I'm just going to multiply everything by L to get a common denominator. Because this is times N, right? So really it's this whole thing, the numerator times N. Especially if I get rid of the L's by multiplying everything by L. So I'm going to get LV equals LC minus this will be C minus S times N. And then I can kind of distribute that in. So I'll get LV equals LC minus NC plus NS. Right? Negative times a negative S is going to give me a positive S times the N. Alright, now this can go to the other side because it doesn't have a C. So LV minus NS equals LC minus NC. And now we have C's in both of those terms. I'm going to factor that out. So LV minus NS equals C times L minus N. Now if I want C, this is multiplication. I'm going to undo the multiplication. I'm going to undo the multiplication with a divide, L minus N. L minus N. And then that's going to give me, that's going to reduce, give me C. So C is equal to LV minus NS over L minus N. I know, a lot of letters. Crazy. Alright, done.